Hello, Christian here with another video update for the pfSense WireGuard package. Before we jump into pfSense and WireGuard package talk, I wanted to spend just a few moments and talk about some of the changes that you might have seen here on my YouTube channel. First and foremost, as of July 8th, I am now working for Netgate on the pfSense engineering team, working on both pfSense and, of course, on the WireGuard package. This has been a really big transition for me personally. I'm really excited to have the opportunity to work on a project, pfSense, a project that I've been using for over 10 years now. Like I said, pfSense has played a very important role in my career, and it will and continues to be a very important component to the stacks that I deploy and maintain. So having the opportunity to work on pfSense is truly an honor, and I'm really excited to work on it in an official capacity as my full-time day job. So before we get into talking about the changes with the latest update, I wanted to also address some of the changes in light of that news, changes to how the package is going to be developed and how bugs can be reported and whatnot. If you've noticed on my GitHub repository, I've closed down the issues section. This is largely because now that this package has been adopted by Netgate, it's now being developed in-house. The most appropriate place to report bugs officially would be the pfSense Redmine bug tracker. So if you're not familiar with Redmine, you can find that at redmine.pfsense.org. And this is the official source for opening up issue reports for bugs. And this includes packages, pfSense Community Edition, and also pfSense Plus. My recommendation for using this for Redmine is obviously do your due diligence in checking the forums and Reddit before making a post on Redmine. Redmine really should be reserved for actual bugs that are repeatable. Just because you have an issue with pfSense or the package doesn't necessarily mean it's a bug. It could be a user configuration problem. So do your due diligence before making a post on Redmine. We'd like to keep this to only include actual bugs, because this is what we use internally for tracking issues and resolving them. So again, my recommendation would be to check the forums, post on Reddit, and if the community is unable to resolve your issue, the community does a pretty good job at teasing out what are bugs and between bugs and user error. But if you're convinced that there's an actual bug in pfSense or the package, then you can go on Redmine and make a post there. You have to create an account, but it's really straightforward, and this will be the central issue repository that I'll keep my eye on for responding to bugs related to both, again, pfSense and, of course, the WireGuard package. Now, with that being said, there's been a lot of development going on. I know that there were some questions on Reddit about what's going on with the development of the package. Has the pace changed, et cetera, et cetera. The answer to that is there's nothing to be alarmed about. Now that I'm working on this full time, I have a lot more freedom in, refining things, and there's just been lots of little changes that I haven't just pushed back up to GitHub. But they will be there. The package, again, is going to be continued to be developed and supported for both pfSense Plus and CE. So that's not a concern. So yeah, there's still a lot of stuff coming down the pipe. And development will still be happening in the open. And I will still be making YouTube videos talking about the project and the progress and engaging with the community and building things that you guys want. And yeah, so that's kind of the state of pfSense, the pfSense WireGuard package sort of as a whole. Again, I'm now working on this in an official capacity as my full-time job, and I'm really excited about it, and I hope that you guys are too. So if you have any questions about that, again, feel free to post in the comments, post on Reddit, forums, whatever, and we'll be more than happy to answer any questions about that. So I thought what we would do today, instead of just kind of going through the changes, I've seen a lot of questions on the forums about how to actually use the package, and there's a lot of new users that have joined this project recently, now that the package is now available in the stable branches, and it's easier to get, early on in this project, getting the package required sideloading precompiled packages that I was providing on GitHub, or using the unofficial repository that some guys that are helping me out with the package built. It was a little messy to get the package, but now that the package is actually in the official package repository in pfSense, it's super easy to get. And there's also currently something that we're working on is the documentation, because the original WireGuard implementation was a little bit different than what we have now with the package. The documentation that's available through the official Netgate docs is not entirely accurate anymore. Conceptually, it's still WireGuard, but the actual nuts and bolts of what to click and what to type has changed a little bit, and there will still be changes coming down as well to support new features that I plan on working on. So the documentation is sort of still in flux, which is why I think these kinds of videos are going to be really important for using the package. So what we're going to do today, in order to do two things: number one, we're going to talk about the changes, and number two, we're going to kind of get everybody that's joining in now, we're going to kind of get everybody on board with using the package. And in this video, I'm going to walk through how to set the package up in a Road Warrior type deployment on a vanilla, fresh installation of pfSense. So that's our agenda for today. And as we go through that process, not only will I be talking about how to set that up, but we'll also talk about some of the changes that have been made in the latest version of the package. So the first thing we're going to do is we're going to install the package by clicking on System and going to Package Manager and clicking on Available Packages. And then we're going to just search for WireGuard. And there it is. So we'll click on Install and Confirm. And this is going to install the WireGuard package onto this pfSense box. All right, once that's done, we can click on VPN and WireGuard to go into the WireGuard configuration. Before we get into actually creating our tunnel and our peer, we're going to first jump into the settings page and talk about some changes there. The first change is that I've added a global enable disable WireGuard checkbox. This checkbox here will override any of the individual tunnel configurations. So even though you might have tunnels that are enabled, if you uncheck this, it'll actually disable the service and will prevent WireGuard from actually starting at startup. So I'm going to go ahead and click on Enable and click on Save, because I do want WireGuard to be enabled before I start creating tunnels. But this is sort of just like a one-shot button to enable or disable WireGuard. You might have lots of tunnels and you might just want to temporarily turn WireGuard off. So you can just uncheck that and click on Save. And when you do that, under Status and Services, you can see that WireGuard is disabled. So that's kind of a little neat UI thing there. So I'm going to go ahead and click on Enable because we want this enabled. I guess I'll go ahead and talk about some of the other settings too, just in case there's anybody that's new to the package. The Keep Configuration setting does exactly what it says on the tin. This is default on, so enable. And with Keep Configurations enabled, your tunnel configurations and your package settings and whatnot will persist in your config.xml if you uninstall or reinstall the package. For the most part, you probably want to keep this enabled because it ensures that, regardless of updating the package or reinstalling the package or uninstalling the package, that your configuration will always persist in your config.xml. The next setting configuration is the endpoint hostname resolve interval. I think it was my last video or the video before that, I talked about the addition of this feature, but this controls how often endpoints are re-resolved, host names. So peers can either be v4 or v6 addresses, or they can also be domain names. And because WireGuard only does the DNS lookup once when the tunnel is built, it's up to the WireGuard service that runs to actually re-resolve those endpoints and update the kernel accordingly. And this just sets how often that process happens. So the default is 300 seconds or 5 minutes. You can set that here, or you can just choose the track system resolve interval, and this will just mirror the alias's hostname resolve interval that's already configured in pfSense. This is, again, 300 seconds, but this number controls how often pfSense will update firewall aliases that contain host names. So it's up to you. You can either just leave it as 300 or check the track system resolve interval, and both will accomplish the same thing. The next option, this one's new. The interface group membership option controls the interface group that is created for WireGuard interfaces, and by default, all WireGuard interfaces are a member of the WireGuard interface group. So this is the interface group that you would see under Firewall Rules, WireGuard. Currently mine's empty because this is a fresh installation. There's no tunnels here at this point. But this WireGuard interface group is an interface group that covers all the WireGuard tunnels on this particular pfSense installation. And the default configuration is to include all tunnels as a interface that's part of that interface group. So the default is all tunnels. You might choose to select only unassigned tunnels. And when you do that, any WireGuard tunnel that's assigned to a pfSense interface will not be a member of the global WireGuard interface group. And firewall rules will then have to be applied to the individual interface rule set. So again, you can choose which option that you're going to go with. If you have a combination of site-to-site VPNs and Road Warrior setups on your same pfSense installation, probably the better option is to choose only unassigned tunnels, because what that will do is it'll allow you to apply firewall rules to your Road Warrior subnets using the WireGuard interface group, and then any of your site-to-site VPNs won't even be evaluated under the WireGuard interface group rule set. They will just be only the individual interface rules would apply in that case. So, it doesn't really matter in this case because I'm only setting up a Road Warrior, so I'll just leave it as the default and leave that as all tunnels. And then finally, the last setting here is purely a cosmetic setting, hide secrets. When this is enabled, it will actually hide any key in the user interface that would be considered a secret. So this would include your private keys and pre-shared keys. And it'll actually just turn those into dots so that you can't see them. Somebody couldn't, look over your shoulder or, a screenshot or whatnot to actually grab your keys that way. So I'm going to just click on Save, and we're going to go back and create our tunnel. So we're going to click on the Tunnels tab. We're going to click on Add Tunnel, and we're going to give it a description. We'll just say Remote Access. The listen port we need to note because we're going to have to create a firewall rule to allow UDP on this particular port. So I'm just going to keep it as the default of 51820. And we also need to create an interface key pair. So we're going to click on Generate, and that generates a private key. Notice that the private key is hidden because of the Hide Secrets option, and the public key, which we actually do need to copy, that's exposed. It's not a secret. But we're going to need that because we're going to have to transfer the public key to our actual client, whether it be a laptop or a cell phone or whatnot. Next thing we need to do is actually give this particular interface an address. So there's two ways that you can do this for WireGuard tunnels in pfSense. You can either assign the interface addresses here, or you can assign them through the interface assignments as you normally would with any other interface in pfSense. Now, why would you choose to assign the WireGuard tunnel to a pfSense interface? Well, it really depends on what kind of deployment you're doing. If you are just going for a Road Warrior type deployment, you don't really need to assign the WireGuard tunnel interface to a pfSense interface. In that case, the only way that you can assign addresses is through this particular page. However, if you're using WireGuard for site-to-site VPNs, and you actually need to establish a gateway and point traffic and actually nudge traffic for particular subnets down a WireGuard tunnel, then you're going to need to assign that in pfSense and create your gateway and do your policy-based routing. That's a video for another day. Not going to talk about that. I actually created a video I think it was a few months, about a month ago, where I talked about setting up Mulvad with pfSense, and that would be considered a site-to-site VPN because I actually want to route traffic to Mulvad as, doing policy-based routing. And in that case, I needed to actually assign that WireGuard tunnel to pfSense so I could do policy-based routing. But if you're doing a Road Warrior type deployment, you don't really need to do that. So I'm going to define the interface addresses here, and I'm just going to choose a subnet. We'll just say 10.1.15.1/24 for a v4 address. If I wanted to do a v6 address, I could just hit add address and I could add a v6 address, but I'm not going to do that here. And we're going to click on save. So right now I have my WireGuard tunnel created. I do need to hit apply changes to actually tell the subsystem to actually create that tunnel in the backend. So I'll click on apply changes, and that's going to do all the magic on the backend to make that happen. And if we click on status, you can see that we have one WireGuard tunnel. There are no peers. You can see the address that was assigned to that particular interface and other relevant metrics. All right, so I think the next thing we're going to do is we're going to go ahead and create firewall rule. So we're going to click on firewall and rules, and we're going to go to whatever your WAN interface is, and we need to open up UDP port 51820. So we're going to click on add. We're going to choose UDP and a pass rule, source any, and the destination port is going to be 51820, and we're going to just say allow WireGuard remote access, and we're going to click on save and apply. So now we have allowed remote peers to access the WireGuard tunnel interface that's sitting at port 51820. The next thing we need to do is we need to actually allow traffic from our WireGuard peers, from the WireGuard tunnel. Excuse me. So we'll click on WireGuard, the WireGuard interface group, and we'll click on add. And we'll just allow everything for the sake of demonstration. And we could allow the source address to be any. I'm going to go ahead and scope that to the tunnel network that we defined earlier, which was the 10.1.15.0/24 network. So I'll type in 10.1.15.0 and then put the subnet, the CIDR mask there. And we'll just say allow from remote access, and we'll click on save and apply. So what this is saying is it's saying that any clients that are sitting on the 10.1.15.0/24 network are allowed through our firewall. And we have the WAN rule, which is going to allow inbound ingress traffic on port 51820 on UDP. Now the next thing we need to do is we actually need to set up the NAT rule. So we're going to click on firewall and NAT, and we're going to click on outbound. And by default, pfSense defaults to automatic outbound NAT rule generation. Now, because we haven't assigned this WireGuard tunnel to a pfSense interface through the interfaces assignments page, pfSense is unaware of that subnet. So we're gonna have to override that with a firewall NAT hybrid outbound rule. So we'll click on hybrid outbound NAT, and we'll apply that. And then we need to actually create a static mapping to override the automatic outbound NAT rules that are already in the system. Again, if you notice, the 10.1.15.0/24 network doesn't exist as part of the automatic rules because pfSense is not aware of that interface yet. That's just a current limitation of packages, and there's no way for pfSense to know that that network exists on this box. So I need to create a manual NAT mapping for that. So again, I just clicked on hybrid outbound NAT, and under mappings, I'm going to click on add. And this is a v4 mapping. Any protocol, the source is going to be the 10.1.15.0/24 network, and we're just going to translate using the WAN interface address, and we're going to click on Save and Apply. Now at this point, all the firewall and NAT configuration should be set up. So the only thing we have to do now is create the peer on pfSense and then create the peer client on our laptop or cell phone, and everything should just start to work. So let's go back into VPN WireGuard, and we're going to go to peers. And I'm going to set this up on my laptop so I can do screen recording of that process. But again, you could apply the same process to a cell phone, the iOS app, the Android app, etc. The process is going to be pretty much the same. So we're going to click on peers. We're going to click on Add Peer. We're going to make sure that Enable Peer is checked. Under Tunnel, we're going to choose our remote access tunnel. And under the description, I'm just going to say laptop. And because this is a Road Warrior deployment, typically your Road Warriors are going to be dynamic endpoints because your endpoint is probably going to be behind NAT, and it's a dynamic endpoint. It's not a static endpoint. So we're going to choose dynamic endpoint. I'm also going to choose a keep alive of 30 seconds just to make sure everything stays connected. Now the public key, I don't know what that is yet. So I'm going to go ahead and jump over to the WireGuard client, and we're going to create a tunnel on my WireGuard client on my laptop. So we're going to click on Add an Empty Tunnel. I'm going to call this Remote Access. And the WireGuard Windows client, or any of the clients for WireGuard, will by default create a brand new key pair. In this case, it's already done that. And again, I'm going to destroy this key pair as soon as this video is uploaded. So, feel free to use it. It's not mine anymore. I don't really care. But I'm going to take this public key, and I'm going to copy that, and I'm going to paste that into pfSense. I'm not going to use a pre-shared key, but if I was, I could generate one right through the pfSense interface, and then I could copy that, and then I could paste that into the peer configuration in WireGuard, but we're not going to bother with that. That's, I guess, a topic for a future video. Now, under address configuration, again, this is another area of confusion for users in terms of what an allowed IP is in the scope of WireGuard. It's important to understand that WireGuard actually contains its own routing table internal to WireGuard that actually sits outside of the system routing table. So when traffic hits hits your pfSense box, and the routing table is used to determine which interface to actually send that traffic towards, once that traffic is handed off to WireGuard, WireGuard uses its own internal crypto routing table to determine which endpoint, which peer to actually send that traffic towards. And the way that it does that is through the allowed IPs configuration. So because we're doing a Road Warrior deployment, this is almost always going to be a host route. So a /32 for IPv4 or a /128 for IPv6. Now I need to actually pick what the peer interface address is going to be. So I'm going to go back to the WireGuard UI, and under the interface stanza, I'm just going to say address, and I'm going to say 10.1.15.2/24. So the pfSense side was 10.1.15.1, and my first peer is going to be 10.1.15.2. Now, if I created a configuration for my cell phone, I might choose 10.1.15.3, et cetera, et cetera. So I'm going to go with 10.1.15.2/24 because this is an interface address, so it needs to be on the same subnet segment as the pfSense interface side. And I'm going to go ahead and just minimize that, and we're going to go back to pfSense, and under allowed IPs, I'm going to type in 10.1.15.2/32, and we're going to click on Save. The last thing we need to do on pfSense is we need to go ahead and click on Apply Changes, and this will reapply the configuration and actually create the peer associated with that tunnel on the back end. So if we click on Status, now you can see that we have the WG0 tunnel. We now have one peer. And if we click on that, we can see that it's hasn't connected. There's no handshake. And so there's no traffic that's been passed because we actually haven't connected using this peer. I would like to jump back to the dashboard because this was something that we teased on social media a few weeks ago, and we now have a dashboard widget. So a dashboard widget has been a feature that's been requested by a lot of people, and a little over a month ago, a member of our community, Adam Cooper, submitted a pull request for a primitive widget that was more or less just the status page kind of readapted into a widget. And I accepted that pull request and then started improving some of the backend functions and tools that I've been writing to support the package, and adapted those to turn this into a really neat widget. So I want to first thank Adam for the initial contribution and the push to develop this widget. But you can find the new dashboard widget by clicking on the plus sign under the dashboard and choosing the WireGuard option. And we now have a WireGuard widget. Now, the WireGuard widget has a few different configurables. If you click on the little gear, you can see what those are. There's two. The first is the refresh interval. This is a number that just determines how often the widget updates using Ajax. This is not a time in seconds. It really is an arbitrary number that just sort of indicates how many ticks of the refresh, the internal refresh clock, so to speak, on the dashboard, the WireGuard widget is updated. The fastest that this can update is a refresh interval of 1. If you choose a refresh interval of 0, the WireGuard interface, the WireGuard widget won't actually update. And then finally, the activity threshold. This is a number in seconds that determines an activity threshold, a handshake threshold to determine whether or not a peer is considered active or not. So the default here is 180 seconds or 3 minutes. And I found this to be a pretty good number for teasing out clients that are peers that are actually active and those that are not. And if you don't really care and you just want to see all the peers that are configured for a particular tunnel, you can actually just change this to 0 and click on Save, and the UI will change accordingly. And instead of showing active peers, it just shows peers. Again, this is not an active peer, so the UI changes to just say peers. But I'm going to go ahead and change this back to 180 seconds because I'm more interested in actually showing active peers. So that's pretty much all we have to do on the WireGuard, on the pfSense side of the configuration. So I'm just going to leave the dashboard open, and I'm going to go back to the WireGuard Windows client. And I forgot that I can't have spaces in the name, so I'm going to just change that and click on Save so I can nudge this down a bit here because I want this widget to stay in view. So let's go ahead and go back to our WireGuard tunnel configuration, and let's finish configuring this for pfSense. So the next thing we need to do is actually create our peer configuration. And here we're going to just type in peer. We're going to say public key. And this public key is the public key from the pfSense side of the tunnel. So I'm going to go back into VPN, WireGuard, and I'm just going to go ahead and copy the public key from this particular, from the remote access tunnel that we just created. I don't need to save that again, so I'm just going to go back to the dashboard, and I'm going to paste that in here. Under endpoint, I need to get the v4 or whatever your public address is for your pfSense box. In this case, it happens to be 45.63.71.134. Again, I'm not really concerned about hiding this address. You shouldn't consider any address private. There's going to be scanners that are scanning for open ports, so have at it. So this is the public address, and the port is 51820. And finally, we need to set the allowed IPs. So the allowed IPs on this side of the tunnel, this is going to determine what the WireGuard client will actually inject into, in this case, the Windows client's routing table. So this is when you have to decide whether or not you want to do a full tunnel remote access or a split tunnel VPN. In this case, I want to just route everything to this pfSense box. I don't want to do, just, individual subnets. But if I did want to do a split tunnel VPN, and let's say that I only wanted to route traffic to the 192.168.10.0/24 network, I would just type in that particular subnet here. That would be for like a split VPN, a split routing situation. But because I want to route everything, I'm just going to type in 0.0.0.0/0. And this will tell WireGuard to create a new default route in this case, Windows, to route everything to that particular endpoint using that public key and that private key on the interface. And everything should just start to work. So I'm going to click on Save, and I'm going to click on Activate. And if everything worked as it should, we should start to see handshakes and data being transferred. So you can see here that our latest handshake was 8 seconds ago. Notice that we now have one active peer in pfSense, and we're starting to pass traffic. So if I go to ipchicken and look at my public address, it's not working. And there's one other step that I forgot, and that is we need to configure DNS. So we currently have no DNS configured on this WireGuard tunnel. So I'm going to just deactivate that and make sure that everything comes back up, and it does. This is my Comtastic address, and we're going to just click on Edit. And under the interface address, we're going to type in DNS, and the DNS server that I'm going to use is going to be the WireGuard tunnel address for pfSense. So that's 10.1.15.1. And I'm going to click on Save, and now I'm going to reactivate. And again, we should start to see handshakes. Again, we have an active peer. We should start to pass traffic. But this time, when I refresh ipchicken, you can see that my address is now the WAN address of this particular pfSense box. And that's how you would create a remote access road warrior type deployment. So just to give you an idea of what the speed test would look like, let's just do a speedtest.net speed test here. And we'll click on Go. And I should be able to easily saturate my internet connection, my Comcast internet connection here without any issues at all. This should just absolutely peg it. And as you can see, this is what I would expect at line rate for my particular internet access here. So it works. And that's pretty much it. So if we go back to the pfSense, you can see that our transmit and receive traffic is now shot up because we've done a speed test and we've transferred quite a bit of traffic. So that's pretty much it for setting up a road warrior type deployment. I hope this video was useful. If you have questions about the recent changes, please feel free to leave a comment down below. If you haven't already, make sure to subscribe so that you don't miss any future videos. Expect more WireGuard related videos in the near future. Again, development is still very much active, and there's some really cool stuff that I can't wait to talk about very, very soon. So make sure that you stay tuned for that. And again, if you haven't already subscribed, make sure to hit that subscribe button and check that notification bell so you don't miss the next one. All right, we'll see you. Thanks.